Hello. Thank you for the introduction. It's a little weird standing here, not actually seeing any audience or anything. I have with me today Erlend, who is, or not with me, but based at home in Stavanger. He'll be joining us and giving the demo part of this. There was a great presentation earlier by Mats and Eric, and a lot of this here is around the history of what led up to that. So I say yes. Is Erlend on for audio, so we can introduce himself? Erlend?
Yeah, I should be on now.
Okay. Erlend will join us later for the technical demo. We have open sourced all of the code for this, and if you take a good look, you'll see that he has actually contributed far more than anybody else, and a lot of this is his work. So let's step forward. So the agenda for today, I'm going to go through a little history of sort of automation and what people have done and why they have done it, and then look at look at the things for automation of systems delivery, and then we'll have a little demo, and then we'll see how it works and what the reasons we are for doing it. So when I say a little history, I really mean some history. So let's get started. So the first thing people think of when they hear about automation and things like that is often Henry Ford and the Ford production line, the Model T and the assembly line. And a lot of people will tell you that Henry Ford invented the production line. And it was very impressive what he did. He took an industry and that was hand producing cars for the very rich, and started making cars for the masses by producing a production line and taking the time to produce a car down from sort of 12 hours down to I think it's down to 93 minutes. And in fact, it went so fast that they had to use black paint only, because otherwise the line would stop because no other paint would dry as quickly. This also had the effect of bringing car prices down to a price of $825 compared to the nearest competitors, which were like $2,000 plus over that. That was a year's plus salary in those days. But Henry Ford was not the first, and not the first by a very long way, to do this. And I think one of the most fascinating things I've seen when researching this was this one. The Venetian Arsenal. So they started building this in around 1104. It took till its height in about 1550 when it was really running the way it was. But it was a genuine production line. It had ships and a canal, and the ships moved along the canal to different workstations where people would build them. And at its height, it was able to produce one new ship per day, and they had 100 ships sort of being worked on at any one time. And this led this tiny little city that grew up on a swamp into being one of the leading merchant trading empires of the Middle Ages, and they needed to protect their trade with boats, and so they built them all in here. And this was one of the first production lines of that. They even had lots of things that we won't see again until sort of the Industrial Revolution, things like replaceable parts, and it was just years ahead of its time. So here is a sort of diagram of, hard to look through, but you see through all of the workstations and number of boats and places where such things were within the arsenal there. In fact, they didn't just have the arsenal in Venice. They also found this was so good, they went and built further ones all the way around the different areas in Europe where they wanted to service and build new boats. So then there was another one that is really interesting, and that was the Portsmouth block mills. And this was built by Mark Isambard Brunel in, 1802? Now, Mark Isambard Brunel is the father of Isambard Kingdom Brunel. And years ago, the BBC ran a documentary series, Great Britons, and they nominated a bunch of people, and then they had celebrities actually run an hour show presenting each of the top 10, and then they had a vote on them who was the greatest of all. And Isambard Kingdom Brunel nearly won. And the reason he won, or nearly won, was because the presenter that showed him was Jeremy Clarkson, and he did such an excellent job. Now, I think that Mark Isambard Brunel was probably the genius. To give your son the name Isambard Kingdom, you have to set him up for greatness. And Mark Isambard was already a great engineer himself. So he created this thing, the Portsmouth block mills. Portsmouth block mills creates these blocks for sailing ships, and the British Navy needed 100,000 of these a year, and they used to employ 60 skilled artisans to create these blocks. And then Mark Brunel built this factory, and it ran with steam engines and that turned milling devices, and through that. And in this workshop, they started to be able to produce 140,000 blocks a year, so nearly a 50% increase. And instead of using 110 skilled artisans, it went down to being 10 nearly unskilled operators. And at the same time, the quality of the blocks that was coming out was increased. Their lifespan increased, and this kept running. This factory kept running until the 1960s. So it was obviously a great leap forward for this. And this was a sort of automated production years ahead of what we consider to be the stuff that Henry Ford did. So. Right, enough of the history stuff. Let's look at some automation for systems delivery. So let's first we'll go through a few of the tools that I've used over the years. So the first here was Make, GNU Make. Actually, I even before that, I remember leaving university and not having any idea how to build a program from scratch, because I was always given little scripts that helped you pull together everything it was, and the magic in the scripts, this was real magic. Then along came Make, and everybody copied and pasted a Make file and altered it slightly, and it went through and just compiled the pieces that you needed and put it all together. And this was a great improvement. We had problems where we used to forget to because you had to compile each separate little piece together and then link them together. You'd build the thing, and then you'd remember, I've forgotten to compile that new component and add it in. Make fixed all that, but it was still very difficult work. And one of the things that I find is really weird is that there's a difference between tabs and spaces. Tabs mean something, and of course you can't see the difference between a tab and a bunch of spaces. Ant was the next improvement to that. So this was platform independent. It was a project that was started when they wanted to build Tomcat, and they had lots of people working on lots of different platforms, and they had to contribute to it. And you had to have one script that could build this rather than 1,000 scripts for each of the different environments. So again, it started to get to more standardized. The configuration was in XML, and it was all platform independent. Then we started using Maven, and the huge jump on this was around convention over configuration. So everything prior to this, everybody's makefile looked different. Everybody's Ant scripts looked different. They were all very much an artisanal setting based on who wrote them and who maintained them. In Maven, everything started to look much more standard. And when I first picked up Maven files, this was the first time somebody could give me something and I could actually work on a project without having to ask somebody, how do I build this? It was great. I would come in, Maven clean install, and it would all work, and I could see, okay, this is great. So that's on the building the software side. But we also needed to automate testing and do regression tests and continuous integration. And so the first of the tools I used for that was cruise control. And this was great. So every time, so a team we had, and we would come in every morning and we would find, because it would do nightly builds, we would come in every morning and find that the build was broken because so-and-so had committed something, and we would find out early rather than finding out a few weeks later that we were all heading off in different directions and breaking this. Very nice, but again, it wasn't as direct as the later things. Then we started using Hudson, or what later became called Jenkins. And this is when it sort of stepped up to more or less what everybody is now used to. You check your code in, and a bunch of configuration in Jenkins sits there, and it starts to run through and build and test and maybe even deploy what you've got. Now, it has been evolving. All of this stuff is evolving. But Jenkins, one of the things that I dislike about it most is its plugin-based architecture. So the repeatability of a Jenkins build is largely dependent on the Jenkins configuration. And hardly any two Jenkins servers are configured the same. So today, there has now just been an explosion in all of these tools, and I've used most of the ones that are on the list here, and there are loads that are missing. This is just a small sample set. A lot of these now come as a service instead of you installing them directly in your office or in your data center. That has some advantages, and it also has some disadvantages around handling of credentials. So there's what led to the CI/CD system that we delivered at V had a few steps before it, and this is the first of them. So what were we thinking? This was at Telia. We had a fairly greenfield site, and we were asked to look at and recommend a way of doing this. And so we thought through this, and we decided we wanted a pipeline-based approach rather than a big monster script that or place for like Jenkins that holds a big monster script that then runs something that you can feed in a number of different steps to, and the thing runs through the pipeline. We wanted it to be reproducible, so everything you declared and said this is how you build it, you could take that and take it to another place and build it again without anything. Again, the snowflakes are beautiful, but having a build server that's specially tuned and does it perfectly for you and nobody else's works isn't really that good. Third thing we were looking at was security of credentials. We knew that there was a lot of secret stuff that we needed to be careful of. We didn't want teams to be able to access each other's secrets. And then we also had an issue around budget approval. We could have just gone out and chosen the most expensive service offered out there, but then we would have been delayed in trying to justify it and prove it, and we needed to move a little faster than that, and so we had to come up with something and show that it worked. And so what did we choose? So here's what we came up with. We had GitHub as our source control. We had Concourse as our CI/CD pipeline, and we used Terraform, and it's part of the automation here. We used that because it was the deployment mechanism that gave us rolling updates. So GitHub was publicly hosted there, and the teams had access to push to their own repos and to nobody else's, all controlled with pull requests and approvers lists. Concourse was installed in AWS but we installed it and ran it. I say we. Christian can take a lot of the credit for this. He managed to get this up and running smoothly, and it was. We had a few occasions where Concourse workers would die, and we would have to go in and manually fix them. But in general, it ran very smoothly and was pretty impressive. And then. But from this, I mean, we'd look at the results from this. So, like the results of the Middle Ages, where the boats led to Venice becoming a huge trading empire. We at Telia, the result of this was that the Telia organisation liked what we had done in a small part and promoted it and said, "Okay, we're now going to want you to do this across the organisation." So I got a chance to do this again, and that was at V. And there we looked at this and said, right, okay, well, we want ultra low maintenance. I don't want to have to restart any workers. I'm not sure I can build it and run it as well as we did the last time. I know I had most of the stuff, but I think there's something we can do with even less maintenance there. I want higher ownership by the product teams, because there was still a part that we delivered this system, and we helped kickstart the projects, but people came back to us to ask for more help on expanding it and growing it and everything, and really wanted the product teams to own their pipelines and to add tests to them and be check that they were running or not down. The third thing we wanted there was some metrics. So again, we weren't really sure of how good this was, but we knew that if we started collecting metrics on how well it did, then we knew that we could see and start tracking that we were actually improving. We also wanted to be able to get teams up and started quickly, but also give them something that was flexible that they could build upon, and it wasn't constraining for the team once they had it. And just like before, security of credentials was a major factor here. And while we had come up with some ingenious ways of doing this at Telia, where we had we'd gone through different methods of using Vault and Secrets Manager and parts like that, and isolating them from teams. And we had chosen to use Concourse because it was on-prem and we wouldn't have to give long-lived credentials to a third party to deploy to our production infrastructure. We had the same things at V, so we were looking at that. One of the other things we chose for V was to loosely couple CI and CD. So the responsibility of CI is to produce quality build artifacts, and so it goes in, it builds them, it tests them, it packages them, and then it delivers the artifacts. and then it notifies the interested services that new artifacts are available, and you can do what you want. Probably test them further and deploy them. So what did we choose here? So again, we went with GitHub and CircleCI. CircleCI we found was the cream of the crop when we looked through for software as a service for CI systems. Everybody liked it. It was fast. It was easy to use. Well supported. So we would write our code, commit, merge stuff to master, or even the stuff that's actually just pull requests would be tested in CircleCI, and then they would be built, sent to AWS, where we ran AWS code pipeline and code build to deploy the artifacts to AWS. And again, we used Terraform because this gave us nice rolling updates when you change the definition of your project. So we this was our sort of first round of this, and we delivered this. But there was a few things that we thought we could do this better. So what do we do? So look, the things that we need, areas for improvement, they were traceability. When the pipeline did not run perfectly, when it was not in the happy mode, what would happen is it would stop, and then the teams would come to us and say, help, the pipeline stopped. Because it was really difficult to work your way through. You had to have quite a bit of knowledge about how code build and code pipeline were set up, where to find the logs, and they were all in like 3 different places, or even 4 different places, because you could also confuse this also with the build logs. And then we had some throughput problems. So this was not particularly fast. And again, like I was saying, the ownership, because everybody came back to us and did this, I felt that the teams didn't have full ownership of that. So so we made a few changes, and that's what we will demo in a little bit. So let's give some background. So I think we gave every team or one of those groups that Eric showed earlier, we gave them a set of accounts, four accounts, a development, a staging, and a production account, and a 4th account, which was a service account that was used that was where you would deliver the build artifacts to, and it would run the automation and push stuff to the other accounts. So here is a diagram of that. Well, I can't see that from here, but if you can see that. So we would take that stuff and we would push to Git, and it would be built and tested, and the artifacts would be pushed into an S3 bucket or AWS's ECR Elastic Container Registry. And the final part of that build step would be to create a JSON trigger file to say what it was that the build process had done, and deliver that as a sort of notification to AWS when it went into that bucket. This then triggers when that file arrives, a Lambda triggers and says, oh, and this is from the account side, it's time that we do something. Let's look to see if we've got something that we can deploy. And it would go take the artifacts from the bucket and from ECR and run a step functions pipeline that we created, that then deployed in parallel to dev and staging. And if all of those tests and everything passed, it would go on and deploy to production. And now it's time for Erlend to take over for the demo.
Yes. Takk for det, Colin. Vi hadde litt tekniske issues i start, men forhåpentligvis så hører alle meg nå. Bare en quick intro. Jeg heter Erlend Ekern, og jeg jobber også i Capra. Jeg har siden i fjor vært på oppdrag hos Vy, hvor jeg har arbeidet på teaminfrastruktur, som Mats og Erik pratet om tidligere. Og en av de tjenestene som har utviklet, og som vi bruker veldig mye ut hos Vy, jo denne her serverless CI/CD-pipeline som Colin prater om i dag. Så nå tenkte jeg å kjøre gjennom en live demo av hvordan denne her fungerer. Skal vi se. Så det vi har satt opp på forhånd nå en full CI/CD-pipeline og applikasjonsinfrastruktur i et sandbox-miljø i AWS. Så vi har satt opp alle de ressursene vi trenger. Vi har en Docker-applikasjon. Så det jeg har lyst til å gjøre å gjøre en endring på koden til denne her Docker-applikasjonen, og så skal vi følge denne kodeendringen gjennom hele CI/CD-pipeline, hvor vi starter med CircleCI, som vi bruker for CI, og videre til AWS Step Functions, som tar seg av deployment-biten. Og så til slutt så verifiserer vi at de nye kodeendringene har kommet ut i miljøene våre. Så akkurat nå så har jeg en container som kjører i et testmiljø. Den tilgjengelig på en URL, og hvis jeg går inn på den URLen så får jeg bare en enkel respons fra en backend-applikasjon. Den sier Hello World. Så det vi har lyst til å gjøre nå å endre den meldingen her, så vi kan verifisere at pipeline får deploya ut endringene våre. Så nå er jeg inne i selve repoet mitt, GitHub. Her har jeg infrastrukturkoden min, vi bruker Terraform, og så har jeg applikasjonskoden min inne i Source. Så dette var en veldig enkel Express JS-applikasjon, som bare gir en statisk respons. Så her ser vi Hello World responsen, så vi kan jo prøve å endre på den til noe litt mer passende. Kanskje Hello Capra. Og så kan jeg committe de endringene. Så det som skjer nå har det skjedd en kodeendring på hovedbranchen vår, og da kommer CircleCI til å sette i gang. Så i CircleCI så det i hovedsak det som Colin prater om, å bygge artefakter og laste opp artefaktene. Så her lager vi en kopi av zip-filen som inneholder kildekoden. Vi laster den opp til S3 i AWS. Vi bygger og pusher Docker-bildet til ECR, som AWS sitt Docker-register. Og når alle disse stegene her ferdige, så har vi en egen mekanisme som laste opp en spesifikk fil til S3 som signaliserer at nå skal vi starte en deployment, nå skal vi starte Step Functions pipeline. Så når det steget nå ferdig, så kan vi flytte oss over til AWS-konsolen. Her har jeg en oversikt over denne her Step Functions pipeline som skal deploye applikasjonen vår. Og hvis jeg nå trykker refresh, så får vi opp en ny gjennomkjøring. Så alle de tidligere gjennomkjøringene her, det tidligere deployment som jeg har gjort. Og nå har det dukket opp en ny, fordi vi har fått en ny kodeendring fra CircleCI. Så jeg kan klikke meg inn på den, og så kan vi følge deploymenten til de forskjellige miljøene i real time. Så det vi gjør at vi starter med, jeg skal bare gjøre dette bitte litt større. Vi starter med parallell deployment til test og stage og servicekontoer. Hvis alt det går fint, så fortsetter vi til slutt med deployment til produksjonsmiljø. Hvis noe går galt under deployment, så stopper pipeline opp, og den promoterer ikke endringene videre til produksjon. Så det som skjer behind the scenes her, at i hver av disse her deploy-stegene, så tar vi faktisk å starte en engangscontainer som vi kjører deploymentene våre i. Siden vi bruker Terraform, så det i hovedsak Terraform-kommandoer, for eksempel Terraform init, Terraform apply og så videre. Men dette kan jo være forskjellige kommandoer hvis man bruker CDK eller CloudFormation og så videre. Og vi kjører faktisk disse her engangscontainerene i Fra Git. Så man kan enkelt sjekke loggene i CloudWatch. Så man får loggene til disse her containerne direkte sendt til CloudWatch, og så kan man følge med på outputen til en deployment i real time. Så hvis jeg ser her, så har vi Capra demo state machine deploy test. Så hvis jeg vil se på hvordan deploymenten til test går, så kan jeg følge med på loggene her i samtid. Og da ser vi at veldig mye her er typisk bare Terraform output, at han sjekker hva staten nå, hvilke oppdatering trengs å gjøres, og så videre. Og så det en endring som har skjedd, og det at ECS-servicen, hvor containeren kjører, den blir oppdatert, og nå venter han bare på at containeren skal bli byttet ut. Så vi kan jo se om det har kommet ut ennå. Nei, så noen ganger kan det ta litt tid før endringene kommer ut. Det har ingenting med pipeline å gjøre, det bare sånn Elastic Container Service fungerer når du kjører en running deployment av containerne dine. Men man kan følge med på loggene her i samtid. Etter hvert så kommer endringene til å komme ut i vårt live-miljø. Og så kan man følge med på flyten i hele pipeline. Så nå ser vi at deploy test, deploy stage, de holder på å deploy ennå. Deploy service ferdig. Og når vi har gått gjennom deployment til test og til stage, så fortsetter vi videre til prod. Så hvis jeg tar og refresher nå, så har vi fått hello Capra. Så nå har endringene våre kommet live ut i test- og stage-miljøene, og så kommer de til å bli deployet til produksjon etterpå. Så det som veldig fint med AWS Step Functions, spesielt når man bruker det som en deployment pipeline, at man har en veldig fin visualisering av hver eneste gjennomkjøring av pipelinen. Man kan sende data fra ulike steg, så for eksempel for å sørge for at vi deployer samme Docker-bilde til alle miljøene våre, så har vi et steg i starten her, get latest artifact versions, og den tar faktisk å finne ut hva det siste bildet fra masterbranchen, og så sender den referansen videre til alle de neste stegene. Så hvis jeg ser på step output for eksempel, for det spesifikke steget her, så kan jeg se at den sender videre en referanse til Capra demo, som denne her Docker-applikasjonen som vi har, og så har den en referanse til hvilken tag vi har brukt på dette bildet. Og den blir sendt videre til alle stegene i pipeline, sånn at alle deployer samme artefakt. Så input og output til hvert steg i pipelinen kan man følge med på. I tillegg så har man en veldig detaljert beskrivelse av absolutt alle steg som har skjedd i gjennomkjøringen. Så hvis man trenger å debugge på et veldig dypt nivå, så har man tilgang til veldig mye forskjellige data her gjennom Step Functions. Så debugging-prosessen er veldig, veldig god når man bruker dette. Ja, jeg tror egentlig det var det jeg hadde for demoen. Så da gir jeg ordet videre til Colin.
So this was built around AWS Step Functions. And one of the reasons for doing that was because we were not happy with using code pipeline. And as we saw from the demo there, you see when you look at the step functions, you see a single instance running of the state machine. And so this corresponds to a single commit. And for some reason, they decided when they built code pipeline that the visualization of it was the pipeline. And you see job number 1 coming in and job number 2 in progress and job number 3. So when you look at it, and you're trying to work out what's going on, you're not seeing a single run of the state machine. You're seeing the status of the pipeline with the multiple parts in it. And it's contextually hard to see. This was very easy to see through what was happening for your run, your commit. That was one part. AWS Step Functions has lots of other applications, and it links in with a lot of the AWS products and can be run at each part. And you can get asynchronous feedback, so you can start something, and then the state will just sit there and wait for a token to be returned to say that it has passed or failed and can continue on. So that is how we do this with. So you can use a Lambda, which obviously has a time limit for each of the steps in the state machine, or as we have done, we've fire up Fra Git containers to run longer running tasks that can run over 15 minutes and as you like. So here is an example of an earlier version of the pipeline that we created, and you can see on the left you have the JSON declaration of the pipeline, and on the right you have the visualization, and that's what you see in the AWS console. And it's animated as it runs through the process. Yeah, and again here is one from the demo you just seen, and so here's the code that actually ran in one of those deploy steps, where we simply say take this little script and run it in this step in Fra Git. So in this case, it's a Terraform init and apply after assuming the role in the account that you're going to be deploying to. So yeah, Step Functions versus Code Pipeline. As I said, the user interface is just, to me, was so much better, and I found that this was generally the feedback that I got. We could trigger it in so many different ways. Code Pipeline was very much dedicated to a concept that it had to be triggered by a source. That source really was supposed to be like S3, perhaps code commit, and you had to put in some sort of hack to make it work with a hook to trigger an event in S3. So it was very limited in how it was supposed to work. It was designed to work with a very limited set of things and was not flexible. One of the things looking for this for the future is that Step Functions as ideal for data pipelines. So the next step of along the lines for this will be to process data for ML projects, pre-prepare those and include those in the pipeline. This adds a dimension of complexity to it, but it's something that the code pipeline and things will not be able to do, and Step Functions are ideally suited to. And as I said, it allows you to do asynchronous steps, so that you can fire something off and it'll run and then come back and do that. Report the results. So I said we used Fra Git to do our deployments and testing in there. So each task that once something's deployed, Fra Git containers run the extra task. And this was highly influenced by Concourse and CircleCI. The concept is you just give you specify a Docker image you wish to use. You specify a zip file you wish to upload and unzip into there, and you say then run this command. So you just say, okay, I want this content here in this image, and right. So you could, in the cases we're doing here, we have a Terraform image, and we upload the Terraform files, and we say Terraform init and Terraform apply. We were doing this before in code build. But code build we discovered was very slow, so the startup times were really slow, and the configuration options were, again, there were 4 or 5, but we tended to stick with just one, and it wasn't particularly flexible. And the price actually, it wasn't really what we were looking to save, but when it comes down to it, the price of code build was 3 times higher than running your own builds in Fargate. And Fargate's a managed service provided by AWS and as easy to access. So we really liked that. So the key features of the whole sort of setup we had here is that it was serverless, on-demand, software as a service wherever possible. We didn't want to run any things that we had to manage, or that would people would come to us and saying, we're blocked because of you. We wanted to enable other teams to have a system that they could use that was based on well-run managed services. We also want no long-lived God credentials to be exported to external systems, and by actually having the AWS environment deploy to itself, that solves a lot of that. It isn't any system where you automate the deployment of something, you are in fact injecting code into lots of places. You have risks, but we felt that we've managed to scope those down to there's as good a place as we can get to. There's maybe a little more to do there, and it's flexible and expandable. So where can you learn more? Well, all of this has been open sourced. Here are the links to the 2 of the key parts of that. One is the example setup, and the other is the Terraform single task. And the other things to think of is, well, where are we going to next? And look at this. I mean, the market moves on and everything evolves and things get greater. So actions looks to be the way forward for a lot of this. So actions are the way forward on this, with the code and the tasks that run on them living closer together. And again, I see this as good with the split from CI/CD. So the actions happen on the CI side, and it delivers the content to where a delivery part's on. And then the other part is I'd like to see how we can do more flexible deployments, canary deployments, and I've been struggling to get my head around how you do canary deployments continuously, and how you roll back and into what state you roll back into, and nobody's really ever come up with a good answer to that. So from that, anybody, any questions? So, okay, well, thank you very much, and that's it from me.